Hello, my name is Kostas. I work as the technical artist teacher at the Game Assembly in Malmö, Sweden. This video is a part of a video series called Getting Started with ShaderFX for Maya. And in this video, I'm going to show you how to create a triplanar ShaderFX shader. Triplanar as in triplanar projection. Now the model I'm looking at is a model from Lee Perry Smith. And I found a free-to-use texture online. It's a tiling texture of a hedge. And the point is here that the triplanar does not use your traditional UVs, which are laid out by the artist. Instead, this texture is projected to the surface based on what direction the surface is pointing in the world. So the top of the head would be pointing in Y positive and would get a projection from the top. The same projection is used on all surfaces pointing downwards. Any surface tending towards the x-axis would get a projection from the x direction, and same with the z direction. And somewhere in between here, you would find a seam where the x meets the z projection and y projection, etc. So likely somewhere in here I can see the leaves is not really working perfect, but definitely for this type of texture, I think it's most of these cases it's good enough. I could highlight it a bit more if I did something like this, and you could see specifically where the edge goes. But unless you look really hard and at this kind of distance, this works perfectly fine. And as I rotate this around, it will seem as it's floating around a bit, but it's just constantly updating to get the correct direction for that lean angle. Right, so enough of that. Let's get started with creating this type of shader. So here's a new shader, and if I open it up, first thing I want to do is get rid of the default shader, because my intention here is not to plug it into all of these fancy inputs, but rather to show you the principle of triplanar, and then you can do whatever you want with that. So for that reason, I'm going to use my base shader just to be able to output color. I will need a vector construct and plug that in here. And now I can just play around with feeding RGB values here, for instance. So as I mentioned, the core feature of or core principle of a triplanar shader is to use projected textures instead of the traditional UVs that an artist would lay out. So let's start with the texture map, and I'll show you how that works. So in this texture map, I will just load up the texture, and let's get the vegetation hedge, like so. And if I were to place it on here, I would have something like this. I'm not entirely sure how the UVs look currently for this face. I can see that there's a lot of stretching and whatnot going on here, but it doesn't really matter. We won't be using those UVs for this shader. So we're going to play around with what we feed into the UV input here. Now, if you imagine that I want to project the texture down the x-axis, like so, I could even go as far as to say in this axis to have an orthographic view. So I'm looking down the x-axis. I want to use the z and the y-axis as my coordinates. So if you imagine just projecting down this axis, I want to use these. This one would be my v value and this would be u value. And what I actually want to get in order to use these axes as my extra coordinate system, if you will, is the position of the vertices. So whenever I sample a given point here, for that point I want to know its position translation value for the y and z, and then with those two I feed them into the UVs, and it should be that simple. So if we search for vertex, and you'll find vertex world position, this one. So this one gives me the combined data stream float3 with the x, y, and z value for the vertex world position. So as we mentioned, if I want to just grab the y and the z component, I'll have to grab a vector component, which lets me break up this float3. And remember, I wanted the y and the z value. So I'll need to construct, and finally this one we want to go in here. So float2 will grab this one and this one, and to make this a bit more easy, you could think of them as the u and v, if you will. Now for my u value, that is the horizontal lookup, I want to use the z-axis, and for my v value I want to use the y-axis. So for that reason, z will plug into x, which represents my u value, and y will plug into y, which represents my v value. Now if we have a look at this, I get this type of result. That is actually correct. I mean, it's tiling a lot, but it is projecting from the right direction. If you see from this direction, not at all correct. But it doesn't matter, we'll use a different projection direction here. So let's start with just tweaking that tiling a bit, because it's a bit painful for the eyes to view that many small leaves, if you ask me. So multiply, and it should be fine just to use a single value. I don't need to tile differently in y, u, or v. I can just tile uniformly for both u and v. So I could actually either multiply at this point, or I could multiply here as well. Both would be fine. I think I'll multiply at this point, and you'll see why in a bit. So with this value, and I could go ahead even now to start exposing these if I want to. I know I will be wanting to keep this one, so I'll call this one tiling and expose as material input. Now if I set this at 0.1, for instance, I can even go smaller, I think, or bigger, like so. This is a lot more easy to look at and see what's going on. And as you can see, it works fine from this direction and this direction, but not from front and not from top or bottom. That's fine, we'll get to those in a bit. Another thing I want to do is, since this is a color texture, I want to, on my texture map, I want to click the convert to linear space. I need to do that to get the correct color representation, since this is a color texture. It's a different topic on its own, but the way I like to think of it is, if it's a texture which was either a photograph or hand painted by an artist because they chose those specific colors because it was aesthetically pleasing, in those cases you want to click this one, because you will be having a texture which is in gamma space, and before you do any kind of calculations with it, you need to first convert it in linear space. And what's actually going on now is that finally, when it's being rendered in the viewport, the Maya viewport is converting it back into gamma space. So you could think of it as Maya, as it's set up now, Maya is assuming that it's getting a linear space color value here, because it casts it back to, or transforms it back into gamma space. And if it's not, if I have a gamma space value coming here, and then I convert it to gamma space again, it'll be overly bright, like so. So click that one if it's a color texture, is the short of it. Right, so let's try setting up the other one. So the point here, if hasn't come across yet, is that we'll want 3 different directions of projection. We'll want one projection looking down the x-axis, one projection down the z-axis, and one projection down the y-axis. Now the thing is, all of these will be using the same texture source. I wouldn't want to, for the user in the end, if I click this one and I expose it, I wouldn't want the user to have to input 3 textures here, all pointing towards the same texture. It would be much more nice for the user to just plug in one of these, right? Now, there's actually 2 ways of going about it, or 2 ways that I'm not familiar with. One way, which I'll go for first, is where we use 3 different texture samplers. It's a bit more expensive. And the last one, which is really easy to convert to, I'll show you that at the end, is how you can make an optimized version where you just have one texture sampler and you play around with modifying the input UV to a greater degree. So let's start with the 3 texture sampler approach first. So what I want to do at this point is, if you have a look inside of the texture map group, you'll see that inside of here, it's actually these 2 nodes, or actually this one, which handles pointing towards my texture on disk, and this one is feeding into that one. So what I want to do is I want to lift these 2 nodes outside of this group, and as they sit outside of here, I can then have 3 copies of this group without these and feed them in here. I'll show you what I mean in a second. First thing though, I want to first make sure, I mentioned this in an earlier video, but since this is a reference to a shader group on disk, if I were to modify this and then save my Maya scene and close it, when I open it up again, my edits to this referenced node would be lost. So if I want to go ahead and start messing with this one, I would have to go group and make group unique to make sure that I don't lose my changes. So you see the R is removed from here, which means that I'm now good to edit this and it'll keep my settings. So if I go in here, I want these 2 nodes and they need to be outside of the group. And if I were to remove these, I need to then take their output and feed them into the group here, and then those need to feed in where they were previously connected. So the way I'll approach doing that is, I see where this texture is going, like this connection, and I grab a new one from here and I start replacing these, like so. And then you see this brown one as well needs to go here. And now this one is not feeding anymore, so I'm good. It's now disconnected, if you will. The texture type, however, I need to do the same thing. So texture type, I do not need to replace this one. Since I'll be lifting both of these nodes out, I'll just keep this connection between them. These 2 connections, however, I want to expose out of the group. So I'll go like so, and then grab the same one and go here. And now you can see that these 2 are completely disconnected, which is what I want. Now remember, as I mentioned several times before, do not Control X to cut. That does not work well with ShaderFX. If you do, just hit Control C and you should be good to undo, that is. Control C and Control V works fine though. So I'll Control C, I'll paste it out here, then I'll go inside and I can just delete them now, like so. And lastly, I can now hook these up to these new inputs I exposed. So in here and in here. That should be good. Now remember, this is the node that is exposed. This one. Actually, I'll just enable the property panel so I don't have to move this about to show the properties all the time. So there you go. It's now, this is the node that exposes the texture. And the unique name is the one which is going to show in the UI, which is exposed to the user. So I can go ahead and call this color. Color should be fine. Now if I look out here, you see it says color. Right, so now the point why I lifted this outside is that I can now go ahead and duplicate this. So I have 3 copies, and all of these can get the same input texture and texture type. That way I only have one texture map in the UI and I'm only pointing once to a file on disk. If I did not, if I used the standard texture map without modifying it, there would be no way for me to just have it as one texture input for the user. I would have to 3 different ones and hope that they point towards the same texture. Right, so that should be good. I can now move this to the side. Now the trick here is that we need to make sure that all of these represents those 3 different directions. So in order to not confuse myself, I'll start adding some notes to this as well. So note section, I think I'll just, actually I think I might on this one, or both perhaps. This is the Z Y projection, since it's first Z and then Y. So I'd refer to this as ZY. And you could even here as well, ZY. All right, so let's just grab one of the other projections. So if I wanted this from the front, I would need to use X as my U direction and Y as my V direction. So I need a XY projection. Now, XY projection is actually the first 2 components, right? X and Y. I don't need to grab the third or swizzle them around or anything. So once I get to the vector component, I already have the XY projection. So that one should be fine to use as it is. I won't need a vector construct in this case. So if I plug this in here, I can start moving this up here like so. This should now be my XY projection. I'll type XY in the note so I have the name up here. And let's try connecting this one just to verify. Seems fine. Got a shader and it's looking down the Z direction. Perfect. Right, so the last one is the top projection. Now, this one is not as straightforward because it's up to you, of course. There's no one single correct answer in this case, but in this case, there's more a logical upwards vector. So that's why I've chosen y as my v component for these lookups. But when you look here, should this be the v-axis, or should this be the v-axis, or should it be inverted like this perhaps? Let's just go for one of them, and then we can tweak from there if we feel the need to. So if I have a look here, you'll see that the x-axis would represent my u direction, and the z-axis would represent my v. So I'd want the xz projection to use for the top. So xz. So I'll need a new vector construct. This one is going to be xz, and this one can also say xz. So I'll first need the x to go into x, and z will need to go into y, as these represent u and v. Then grab that float 2, plug it into the UV lookup of this third texture, and let's verify that it seems to be working. And that seems to work fine. Not from these directions, from the top, however. Now the tricky part here is we start composing this together. This direction could, as I mentioned, it could go this way, which it's doing now, or you could flip it around and go that way, or maybe you want it oriented that way. Might be important to get one of those if either direction is more important to you. It might blend better with either this side or that side or the other side. But we'll see in a bit once we have it all working together. So that's fine. I now have 3 directions. And just to reiterate, the point why I put my tiling here is now I can do the tiling once before I split this up in order to build it here. If I had multiplied after this vector component, say here, I'd need to add another multiply here and another multiply here. So it's easier to do it once here, and then it breaks off into 3 different custom UV structures, if you will. So I'm all good with the 3 different texture projections. Next part is to figure out how do we choose which of these projections should be used for which area. And as I mentioned earlier in the video, this is actually based on the direction the surface is pointing in world space. So in order to get that, we should be able to grab the vertex normal for world space. So vertex world normal. Now, if we grab this node and let's just have a look at it for starters, like so, then this is the kind of results we have. So this one actually just represents the surface direction in world space. So notice how the direction this little indicator is pointing is the positive direction. So positive x is when I'm looking down this direction, and any surface pointing straight towards me now is completely red. As it's starting to point towards z positive as well, that is left in this, you'll get more blue. So I have pure blue when it's right at me at this point, and if it's between red and blue, you have pink. And I have green from the top, and variants of green, going towards yellow or teal color or whatnot. The other point is also that I have negative here as well. We can break them up and show them individually in a second here, but this one, since I had positive x here, I have negative x here. And positive y here, I have negative y below. Positive blue or z here, I have negative z here. So in this dark part here, I actually have negative values, probably in all 3 of them directions or vector part components to some degree. Let's focus on just looking at one of those directions, because it's a bit more easy to grasp, I think. So if I go vector component, and we break this up, we'll need to disconnect this one, and let's just grab the x direction, for instance, and show that as R, G, and B. There you go. This is the x component. Notice how I have positive in this direction, and there is actually a difference of value here. It's just going from 0.0 here and all the way to -1 when I'm looking straight at the surface here. So there's equal amounts of data to fetch here. It's just not being represented as a color variation here visually on the screen. So, and we could do the same for just viewing the y and the z. Now, the thing here is, there's actually one part I want to show as well. You have to excuse me. I try to give as much screen space here as possible for me to work with, but I need to actually get this small panel here as well to shift the color space for the viewport. So I will click, let's see if I can figure this one out. This one, yes. So with this one, you would likely have this one on by default. And this is the thing I spoke about, where Maya viewport actually transforms the color space as the last step it does in the viewport. And it's being transformed into gamma space now. I want to just show you what it looks like if I switch to raw or if you just disable it. This one will, I think, if you ask me, more visually show that it goes from 0.0 to 1 here, more linearly growing. When it's in sRGB, it's predominantly bright all the way here. So if I go back to raw, and this is just to illustrate these type of gradients, we wanted, right now we have a good mask. If you think of this as a mask for one of the projection directions, we have a good mask for the projection which looks down the X direction, right? So if you think of the white color as where it's going to be using the X projection, the white color, this works fine on this half of the head. But on the other half, I can't use a white color to as a mask here, right? But there's still that difference. One common factor is that I've got 1 here, 0, and -1 here. So there's still that contrast or change of value that I should be able to use this side. And the way I like to do this is just use the absolute node. The absolute node will simply strip away the minus sign or the negative part of a value, which means that if I strip away the negative part here, my -1 here will turn into +1. So I will go from 1 to 0 and then 1 again. So let's try that. Let's grab an abs node. Oops, abs. Abs. There you go, absolute. Now, I could go ahead and absolute just the X component, but similar to my tiling value, I know that I'll want to use the absolute on X, Y, and Z, so I could go ahead and just hit absolute here instead. So if I just run this by absolute and plug it in here, and then I have a look at my results, I have this now instead. It used to be -1, stripped away the minus sign, and that means I now have +1. So this should work nicely as a mask for where to put that X projection. And same thing, just to show, if I grab the Z part here instead, I think you get the picture, but I just want to show one of the other directions as well. I now have a good mask for projecting in the Z axis. You see it's black here and then white here again. And same for the Y component. So here I now have the key, or the keys if you will, for which projection should be used on what surface. So we should at this point be able to just use a lerp node to blend between these. There's one thing I do want to touch on as well, and I can actually show you what this looks like as a color first, if you will. It will be a bit confusing, but I'll give you a hint. There's likely a problem here, and the issue is that these gradations or the gradients here is on a very long area. So it goes from 0 to 1 all the way here, right? Which means that as soon as the Z projection, looking down this direction, meets the X projection, they will gradually blend into each other over a very long distance. So at any given point, like over here, you might have 70% of the Z projection and 30% of the X projection. Maybe, I don't know, 5% of the Y projection as well. Well, yeah, that would be 105, but you get what I'm saying. The problem with that is it'll just look weird. Basically, you want this transition to be over a fairly small area, not too sharp of an area, because then it might appear as way too sharp and it'll be very visible. You'll see the seam directly. But if you just do it over a short distance, you won't really notice that there's a sharp transition, and also you won't get this effect of there being double amount of semi-transparent leaves on top of each other. But I can show you what it looks like. We can start with the lerping part of the shader. So I won't be needing this to be connected anymore. I want to keep this, as this is my solution for getting those masks. Now let's use some lerp nodes. lerp is short for linear interpolate mix. You cannot type lerp here, you need to type linear or interpolate or maybe mix. Now this one, very useful node, we use it a lot. It's for choosing between value A or value B based on this mix value. And the mix value goes from 0 to 1. So a value of 0 in this one would completely choose the first value, and a value of 1 would choose the second value. And in between, you get a mix of them. So 0 and 1 is the same thing. Oh yeah, I removed my color as a white color or black color. So this one works perfectly when you have black and white masks to choose between two values. And that was exactly what I got from here, right? I had black and white areas on my model. So let's say that we want to blend between the Z projection and the X projection. So let's say that we want the Z projection first. So Z projection should be my XY value. I want to choose this one as, well, it doesn't really matter. Regardless of how you put these, you can choose the correct one here, but I'll put it here. Which means that when this value is white, it'll choose the Z projection. So if the value should be white, to get the Z projection, I should be getting the Z component here, like so. And if you get this wrong, you can just change it up later. It's not a big deal. But the logic here is Z projection, as we viewed earlier, will be white as the surface is pointing towards Z. And this is my Z projection, since it's using the X and Y to make up the Z projection. And the other projection I want to blend with is, I could actually blend to the other one as well, but we settle for the X projection, right? Now X projection would be my ZY labeled here. You could actually rename these to Z projection, etc. But ZY is the one which is my X projection. You could type it like this if you wanted to, right? To be extra clear on what this is. I'll just go ahead and do that to not confuse ourselves. Z projection, and this one would be my Y projection. Like so. Let's copy paste that. There we go. Okay, so I was blending towards my X projection, like so. Now we should have at least two directions on my model. So let's have a look at the results we have going on now. Oops. Bit too dark, and that is because we changed to the raw. That was just to showcase the gradients. If I go back to sRGB and I have the correct colors, and as you can see, I have projection from this direction and projection from this direction. However, here's the issue I spoke of with having these blend like 50% of each texture source. You have these transparent looking leaves overlapping each other, which is not ideal. So we'll have to solve that. Let's just finish up what we were starting with here. The last thing I want to do here is blend in my third texture source as well. So the way you do that is you just grab another lerp node and you take the previous results and input that as your 0 value or your false value, if you will. And then the true value is going to be the third and unused source, which is my Y projection in this case. And I'll place that over here. And since it's my Y projection, I want to grab the Y to drive the mix and then input this as color. Right. So let's have a look. Yep, I have this from the top, and I don't have that transparent thing going on here since it's pointing straight towards me. But as soon as the surface starts, going towards the side, and here is the worst case where I have pretty much all three directions meeting up, so I probably got a third of each texture source here. But at least the directions are correct now, and they seem to match the correct projection direction. So in order to solve the issue with those transparent leaves looking kind of thing, I want to go back to show this again. So for the moment, I'll just hit delete on this one. I'll move this down here, and let's go for the X projection. Just grab any of them, but I'll go for X. And let's have a look. Right, so changing back to raw, here's my X projection. Now, as I mentioned, the problem here is it goes from 0.0 to 1.0 over this entire range, like a fourth of a circle, or 90 degrees, if you will. So the way I want to approach that is, think of it as if you had like a contrast feature like Photoshop or a 2D program. As I increase contrast, it'll move the dark spot way over here and the bright spot over here, and it'll make my transition just over a shorter range, if you will. So the way you add a contrast, a really simple contrast, is you can do that with a few different simple math nodes. An subtract node. Let's see if we get this right. We first want to subtract by 0.5. See if I can open like Notepad or something. Could do some simple math here. So think of this, the projection colors I have already. You can think of that as the value x. Want some bigger font size as well to showcase this a bit better. There you go. So this is my my projection colors I have already, the black and white representation. If I hit subtract a half, or actually before I do that, let's say currently x is 0.0 to 1.0 range. If I hit x minus 0.5, I will make that range into x is minus 0.5 to 0.5 range, right? You can type range here as well. So next thing I want to do is x times my contrast multiplier. You can think of that as any value the user can input. So let's say that the input, for instance, a value of 2. If they input a value of 2, my x will then be, I had this range before. If you multiply this range by 2, the minus 0.5 will turn into minus 1.0 to positive 1.0, because 0.5 times 2 is now 1.0. All right, then I will want to, since I initially removed 0.5, I want to add back that 0.5. The only reason I subtracted to begin with was to get half of my range into negative space and the other one into positive. Because then when I multiply I'll be halfway between this range. Halfway between this range will be like the center point for the contrast, if you will. So at this point, I'll want to add back my 0.5, and then I probably want to saturate the value as well. Saturate, as I mentioned in other videos, is similar to clamping between 0 and 1. So clamp my min value, my max value, and what value gets clamped. These two will do the same. Clamp, you might be familiar with. Any value below 0, it'll chop off that and just throw it away, any negative part. Any value above 1 will also just get thrown out, so it'll stay within this range. Saturate does the exact same thing, but cheaper. Use clamp if you want to use custom min, and max values which are not 0 and 1. Otherwise, use saturate since it's cheaper. So to recap, minus 0.5, multiply by my contrast amount, add back the 0.5, and then saturate. So subtract, and let's just grab one of these directions. Let's go for the x again. And in ShaderFX, you can either add a float value here, and that might be better for visibility, but you can, not on all nodes, but on these I think you can. You can click where it says value here, and then you can type in a custom value here without having to add a float node. I'll do that just to showcase it. More often I actually add a float node to be extra specific. 0.5, and you see that it'll turn into green here, and it shows the value here. Make sure when it's a subtract, it's easily done. You do not want to type minus 0.5 here. If you do, it's like having two minus signs. So minus 5 turns into plus 0.5. You already have minus in the node's behavior in itself. So 0.5. Then let's add a multiply node. And here, this one I definitely want to float because I want this to be exposed for the end user. So, yep, that should be good. This one should be exposed, and we'll go ahead and call this range, well, transition width, for instance. And it should be exposed. Yep. So we've now added, subtracted, we've now multiplied, and now we want to add a half and then saturate. So add. Same thing with this one. In this video, I'll just go ahead and show that I can hard-code a value like this without using a float value. So I've added 0.5, and now we saturate, like so. So let's go ahead and show this value instead. Like so, should be used for red, green, and blue. And now if I have a look, it'll look the same since I'm basically using a contrast of 1, which means no difference. But if I were to say 5, I get this behavior. That might look sharp, but this is what we want actually, because now it'll retain the Z projection all the way here with no change. And here it will retain X projection. And then it's just this little span where it'll blend the two sources together. And let's throw on the textures here to see that in action instead. So let's go ahead and have a look. We want to be doing this contrast operation for the entire source. So I actually did the thing I spoke about earlier myself. I should be doing it here and then breaking out into 3 parts instead of doing it here, because then I'd need to add the same nodes for each of the projections. And I basically want to add the same transition width for all of them. So in that case, I'll need to delete this one, and I'll need to delete these. And let's go ahead and make room and move these over here. And let's see if we can, I'm not sure if we can actually get this one to revert back to float 3 at this point. There is one way. Either I could recreate the nodes, or one way I do it is I do something like this. And then if I disconnect here, I'll have to, there might be a better way. I want to mention that. I'll do this. And then here, how do we get this one to output? There you go. This is what I want. All right, so let's verify that I got this right. This one doesn't seem happy though. I'm not entirely sure why. So if I do this, does that make a difference? Nope. Come on. Why is it not working? If I do this, would that work? It's still flagging as red. Yep. Still some aspect of ShaderFX, which I'm not entirely sure of. But like this, and I should now be able to type 0.5. See, I don't know what the difference is now compared to what I just had, but this should be fine. So the point was here to keep the teal color, which is my float 3, and it was previously locked in, if you will, to a float value. So this should be fine. I'm handling float 3, float 3, float 3, float 3, and it outputs as float 3. And this one is still outputting to my lerps nodes we set up before. So I should be good to just grab the RGB value here. And let's minimize this and have a look. Switch back to sRGB. And here's our results. So it's already looking a lot better with transition width of 5. Let's put it back to 1. This is what we had before. As I set it up to 5, I'm now only transitioning between these sources around here. So you can see a bit of that semi-transparent leaves, and it might not line up that well. As I increase it, you'll likely find some sweet spot which you like. I think 10 was better than 5 in this case. And if I go too high, you'll start seeing like this, where you can see where the seam is. So try it out yourself. You can leave this up to the user perhaps. I think 10 was the nicest one of them yet. This is basically it. This is the shader I showed you earlier. I'll show you in a second just how the optimized version look, but to recap, you need 3 different projection directions. I have X, Y, and Z, and the way these are set up is you choose vertex world position and you choose the 2 correct axes to act as your U and V direction for the lookup. I'm feeding from the same texture source, so I can just have one texture slot in the UI. I've got a tiling value so that the user can set their tiling of this. That is exposed. You'll see this Maya icon to show that it's exposed. This one is also exposed, the texture itself, and the transition width is exposed. So these three sources are being lerped together. They choose either of these based on a mask value, if you will, a mix value. And that mix value stems from the world normal. You just choose the correct world normal to mix into here. The world normal initially had its negative side here, if you think of the x, and positive here. So we had to take the negative side and just remove the negative value to get it positive 1 here and positive 1 here, and then gradually go to 0. And lastly, we added this transition width to make that transition between 1 to 0 a lot tighter. All right, so the next approach, which is definitely better for performance, but might not work that well depending on what you're applying it to, is to not have 3 samplers. This is an expensive part when it comes to shaders, to actually sample the texture. And there is a way of doing this with just one texture sampler, but instead you do not lerp over here, but instead you lerp on the UV where it goes into the UV. So let's try creating one of those. So I think I might, let's see if we can manage this. If I go over here and Control D, and let's place our optimized version on the side here, I might go into the hypershade. I want to go ahead and duplicate the texture source the shader is my plan. So shader 2 I've been working on. If I then go ahead and, how do I do this? Can I do edit? Will this be duplicate shading network? I'm not sure why it keeps popping up my notepad. So this is ShaderFX shader 3. That is my traditional game surface shader. That did not work too well. Right. I was hoping that it would actually carry over my results. So one way I usually do it to be extra safe, but I was hoping there would be a better way, is to actually just export my shader, create a new ShaderFX shader, and then import it into there. So that might give me a reason to show how to export the shader as well. So with a shader like this, you could go File, Export Graph. Let's call this Triplanar 3 Samplers, and hit Save. You'll see that it'll save into your Maya ShaderFX scenes folder, .sfx. And then you can go ahead and close this. On this one, I should be able to apply a new material, ShaderFX shader, open that one up, File, Import, and it should default to this one, and I can select this one. So now I would essentially have a copy of that shader. So let's go ahead and break this one up to make that optimized version. So I think I'll go ahead and delete this one, and these lerp nodes. So now the idea is that this one will go directly here, and I did not need these other texture samplers. The trick is now to, instead of just having this one UV here, I'll grab from here and here as well, and we need to lerp this result. So similar to how I was lerping before with 3 samplers, choosing which projection results after the sampler, I'll now choose which projection UVs. And actually, sorry, my bad, I cannot lerp between UVs, or I could, but it'll give me the wrong results. The one difference you'll notice as we've set this up, with the 3 sampler version, I can have this soft transition. With this approach where we combine 3 UV sources, I'll always have a very sharp transition. So let's see, I think I've got the hypershade open still. That's a big no-no when working with ShaderFX. And okay, it went ahead and closed my other window as well. Right. So I will use if else basic. This will be the one I use to ask the question: should I use projection source A, B, or C, or actually A and B? So let's start with one of them. So the question I want to ask, the transition width won't be necessary at all, since as I mentioned, I cannot use a transition I'd basically just be paying for extra without getting any results. So I can go ahead and skip those. And let's say that we want to choose between using the X projection or the Z projection. So what I want to do now is use the comparison node. And I'll want to ask, is the X projection, with the comparison allows you to do basic comparing of values, like equal to, not equal to, smaller than, greater than, etc. And you can use this in conjunction with if-else basic to choose between two different paths or two different results. So I'll show you. Let's set this up and I can explain it in more detail. So I want to ask if the X projection is greater than, and it would be fine to use greater than and equal as well, it doesn't really matter that much, than 0.5. What this means is that if you imagine that black and white representation, the white represents a value of 1 and the black a value of 0.0. So if I ask, is this the black and white representation, is it greater than 0.5? That means I'll have a break at where the semi-gray is, exactly where X meets the Z projection halfway. And that is how I want to phrase the question. Now then, this one goes into the condition part of the if-else basic. You see both of those are bools, and bools is true or false, like on or off switch. And since I'm asking if the X is greater than 0.5, the true here should be the X projection. Now X projection is this one. So that one goes into true. And the other one, if you remember, we wanted to go for the, sorry, like so. We wanted to go for the Z projection. So Z projection is this one actually. Since the other ones needed to be constructed, this one, the Z projection, works straight from here. So I should be grabbing from here, plug that into false. And this new tweaked UV or combined UV should be feeding into here. Let's have a look, see what that looks like. Yep. So now I am getting the Z project or X projection and the Z projection, and where they meet up I have this sharp line. Now that's inevitable. I can't do anything about that, since I cannot semi-blend between with the lerp with two UV sources. That would not end up nice. It works for colors, but not for UV coordinates. So lastly, similar to the lerp, I now want to blend in my third projection, which is the Y projection. So I need to just repeat the same kind of logic. I'll need a new comparison node. I want to compare the Y, since I'm going to blend in the Y projection here as my true statement. I need to check Y, and I need to check is Y greater than 0.5. So I can grab from the same one, paste it in there. This one goes into the condition. Now this question is Y mask greater than 0.5? If true, then use the Y projection. If false, use the previous results, which is the combined projection of X and Z. Like so. And lastly, this one needs to plug in here. So I've done the same kind of thing we did with the lerp operation. The difference is I'm now I'm choosing between the three different projection sources for the three different axes to project down. And I've got this harsh kind of choice where it's either on or off. There's no semi-blend in between. So I ask these two questions. I've now got a combined three projection directions, and it feeds into one texture sampler. And in this case, I wouldn't need to have this exposed either. I could just have used the regular texture map for that matter. Now let's have a look. So that's what I get. So at distance might not be that big of a deal. You can still see this. But if we were to say place this on a polygon cube instead, let's try that out. So let's make a bigger cube. Let's try the first ShaderFX, which was number 2, this one. And then let's try this one, number 3. And actually, let's move these a bit closer, like so. Now, you will definitely, if you look closely, you will see the seam on this type of more soft organic surface like this, and especially if it's here straight on a surface where there's no clear distinction. On these, however, I bet you'll struggle to see much of a big difference between these two, since there's like this natural cut off here where you have this sharp angle either way, and it still works quite fine, I think, if you rotate this. You don't see any kind of seam straight here on a flat surface, since it's since this is completely flat, it's choosing completely one direction and there's no break halfway in between. So a bit depending on what your preferences is, you can go for the more expensive one or the cheaper one, but it's at least two different ways of going about doing triplanar projection. So I hope this has been useful. Thanks very much.